Here we have a wave indicated to propagate along the positive x-axis, and at its initial position, t equal to 0 and x equal to 0, the y-coordinate attains its maximum positive amplitude. The wave is characterized by a specified angular frequency and wave number. Find the expression for the velocity and acceleration of this wave function. First, let us try to draw the graph to better understand the function that we would be using. So, we use the following parameters for the x values: 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, it says here in the problem that at t equal to 0 and x equal to 0, it gives you a maximum positive amplitude. So we expect that the wave will be starting at the maximum positive amplitude here. Now, for that to happen, x equal to 0 and t equal to 0, the parameter inside the function must give a positive maximum amplitude. So we would expect to be using a cosine function, because if this is equal to 0, this will lead to a positive amplitude as shown here. So that means this is the ideal function that we should be using, because this would give us a maximum positive amplitude. Now, to obtain the velocity of this wave function, we simply derive this one with respect to t, and taking the derivative of a cosine gives you a negative sign, and the derivative of the parameter inside with respect to dt will give you an omega here. So this is the function for the velocity. For the acceleration, we simply take again the derivative of v with respect to t, and we see here that the derivative of a sine is simply a cosine, and it retains almost all of its physical attributes by simply multiplying it only by the angular frequency, and we have here for its acceleration. Another way of solving this is considering the identity of this cosine function, but it has a negative parameter inside, and the identity tells us that this will give you exactly the same value of a cosine theta. So it gives you a maximum positive amplitude if theta is negative. So that means we can also use this function, wherein the function inside is an omega t minus kx. Even if we factor out the negative here, this will still give you a maximum positive amplitude a. So that means we can use that one, and we take the derivative of that one with respect to t, and we have this function here for the velocity, and taking the derivative of v again with respect to t, we get the expression for the acceleration as shown here.